But we have also to provide adequate tools, user-friendly tools, tools that can provide in a visual manner analytic information. And this has been phased actually in the scientific domain, in the academic, by means of geovisual analytics, which is the discipline that aims to detecting potential dangerous information pattern within a complex multidimensional data flow. So I'm speaking about multidimensional geodatabase, which actually I think it's almost two-dimensional or 2.5-dimensional database. And this is done in geovisual analytics, the discovering of pattern information by means of data mining, and also advanced visualization and interactive techniques. So the main challenge of Briseide should be at least achieved by means of the convergence of 4 different factors: visual analytics, requirements that are coming from real scenario, and also the deployment of a real pilot that should be tested in a real environment. And this, of course, trying to exploit the time dimension of the geographical information. So our goals: extend the current data model to support time. ISPIRE, that has been recalled several times, pose a very little attention about the time dimension. Actually, temporal extent of a given resource are accessible only by means of the data creation of the resource data of publication, and the resource data of last revision. So if we have a look on the picture that shows the effect produced of the Iceland volcanic eruption, no reference to when the event has occurred and its time-wise evolution. So more technically speaking, we don't have any temporal information about the topological geographical information embedded in a shapefile. And of course, we don't have any spatial temporal operator that are able to process geographical information and its temporal information. Especially, considering web services spatial operator. And as far as I know, no pilot-specific processing based on web services is available up to now, funded by European projects, for instance. Several European projects have been founded in order to exploit the temporal dimension, but actually no real pilot has been deployed so far. And this has to be developed in a modular infrastructure. We have to also preserve or at least ensure the accuracy of information. Of course, this picture is a bit provocative. No one of us will believe that in the middle of the Colosseum there is an hotel or a restaurant. And of course, this information has been provided to Google and no accuracy is required. But to ensure accuracy, we have to be sure that who is owning the data is the one also that will care about the definition and the distribution of the data. And this has to be embedded in a way that it can be also those kind of functionality processed within the actual spatial data infrastructure. So providing interoperable access to processing feature as remote services. So WPS. And we have to deliver new tools, new functionality. And the picture that we saw yesterday of the policeman addressing several hardware facilities cannot be something that we can accept much. And of course, even in a research project, some specific result has to be validated in a real operational scenario. And this is why the pilot operational phase will last 12 months after the end of the project and will consider real-life events. So project facts and figures. It's important to use and reuse existing technology. And this was why Briseide already established a liaison with the numbers of European projects in order to exploit and reuse what has been already developed in several projects. Furthermore, the Briseide services are not strictly dependent on a specific dataset and can be potentially applied to many application domains. Services developed will use existing pan-European dataset made available by public administration, including regional government. The pilot, I will be very short on that, but I think it's important to give you an understanding of the operational scenario we are facing actually. So the first one is about earthquake. The geographical area where the pilot will take place is Italy, and we will not consider the effect, the direct effect provoked by an earthquake, but we will consider what are so-called co-seismic effects. So, if situations that are provoked after or are consequence of an earthquake. Then forest fire, flood simulation, sustainable forest management, landslide monitoring of hydrological disturbances, and energy management pilot. So we also consider the vehicles that usually are used in compiling natural disasters. Now I would like to give you a technical overview, not very technical, I would say, but at least give you an understanding and presenting what we are actually developing. So the system architecture of Briseide is a typical SOAP architecture. So it's characterized by three levels: the data level, the middleware level, and the application level. The application level that we are considering to develop is an Eclipse-rich client application using the plugin technology. So the user will be able to customize the interface and to customize the functionality in your required. And this will satisfy the development of a very thin client. Of course, we are also considering property technology, but the interoperable one. So each kind of property technology can interact directly the middleware level or the data level if they are satisfying the OGC interoperable standards, so to say. Just a bit more in detail, exploiting the middleware level, actually you can see that we are considering the red box data preprocessing services, fundamental for ingestion of data, so the user of existing spatial data infrastructure, for reprojection of the data. The data access service layer, that is the orange one, provided by the use of OGC standards, so WFS, WFST, WMS, WCS, and also metadata server or other kind of server that can be alphanumerical data server or server of data coming from a sensor. Then, on the green box, we are considering the value-added services that will exploit the temporal dimension. And those kind of added value services will be generated by the use of existing technology, satisfying the specific requirement of the operational pilot that we are considering. So, forest management, fault simulation, change detection in real time, and also we are considering some more general services, so geocoding, GRSS, and routing services. On the left side, you see the blue box, and also those kind of services can be considered the general services in order to satisfy the credentiality of the user, so user authentication, and also cataloging and discovering services, but in this case, considering the temporal dimension.